Hello everyone. Today I am going to talk about Moore Sequence Detector. Yesterday I discussed Mealy Sequence Detector and today I will discuss Moore. So now this is the input given. We have to detect 1, 1, 1. Now let's start. Yesterday I told you a method to write the output values once. So let's see that. What we want is 1, 1, 1. But our starting is 0, so I'll write 0. Next comes 1. Again it doesn't match with it, so 0. 1 again doesn't match, 0. Then we get a 1 and previous two values were again 1, so the sequence 1, 1, 1 is detected. Hence I write the output as 1. Same way, next 0, I'll write to 0. Then 1. What here we get is 1, 0, 1, which doesn't match 1, 1, 1. So again 0. Then followed by 1, 1. They don't match. So 0, 0. And then 0 again. And final 0. Next what I see is 0, 1, 1. Doesn't match, 0. Then 1, 1, 1 matches. My output is 1. And then finally last value is 1 and previous two were 1. So 1, 1, 1 matches 1 again. So this is my output sequence. Now the major difference between Mealy and Moore is that in Mealy circuit we used to give the representation of states as, say this is S0, and suppose my input is 1 and output is 0. So I'll write it as 1, 0 like that. But if you observe here, we write the output value in the same circle as in which we write the state. So basically we represent the output and the state together. Now here we need to detect 1, 1, 1, which means we need 4 states: S0, S1, S2 and S3. Now initially S0 by 0 because only first state and we need 3, so my value of output will be 0. Then next if it is 1, it will go to S1 but my output will still remain 0. Again if the next value is 1, it will go to S2 but my output will still remain 0. And next if my input is 1, it will go to S3 but here you see, sorry this should be 1. Here you see my output will become 1. So this is how I represent my state. Now we'll see here. Initially input is 0. So 0 it stays at the same state. Next is 1 goes to the next state. Now again here if it is 0 it will go to the previous S0. If it is 1 it will go to the next state. Here if it is 0 it will again go back to the first state because the previous state was 1. So it cannot go back to the previous state. Next, if it is 1, it will go to S3 and my output will become 1. And in S3, if it remains 1, it will remain in the same state. If it is 0, it will go back to the first state again. Now, why can't it go back to any of the previous states? Why? Because the values of the states are 1 everywhere except the first initial state. So I hope this is clear. Now let us see some previous gate questions. So the question is, a sequence detector is designed to detect precisely 3 digital inputs, and the trick here is they have given overlap in sequence. Now they have given this is a sequence which has to be detected, which is 1, 0, 1, and the input is this. What is the output data? Now let's see. Here what I will do is I'll make groups of 3. So my first group from the input data is 1, 1, 0. It doesn't match with 101, so I'll write a 0 here. Next group is 101. It matches, so I'll write a 1 here. Next group is 010. Doesn't match, so a 0. 100 doesn't match, 0. 001 doesn't match, 0. 011 doesn't match, 0. Doesn't match, 0. 101 matches 1. 010 doesn't match, 0. 101 matches 1. 011 doesn't match, 0. 110 doesn't match, 0. So when I compare the options, option B matches. So that is my answer. Now let's see another question. This is a bit of a different question. We are asked to find the state transition diagram of the given circuit. Now in the circuit here we have a D flip-flop, we have a 2:1 MUX and a NAND gate. So basically let's draw the truth table first. I will assume my Q to be 0 first. So if Q is 0, Q bar will be 1. Next, if A is 0, it will take the value of Q bar. If A is 1, it will take the value of Q. So let me assume my A to be 0. So if my A is 0, what will be my output here? At 0 the value is Q bar. So Q bar is 1 and here Q is 0. So 0, 1, NAND is 1. So D value is 1. Now if my D value is 1, my Q bar, the net state of Q is 1. So Q is 1, Q bar is 0. I'll again assume A to be 0. If A is 0, I'll get the value of Q bar here. The value of Q bar is 0 and Q is 1. So 0, 1 NAND combination will again give D as 1. Now if D is 1, Q bar is also 1 and 1, 0. Now here again I'll assume my A to be 1. If A is 1, it will take the value of Q. So if my Q is 1 and here also another input is also Q. So 1, 1 NAND will give me 0. So D is 0, Q bar is 0. I mean net state of Q is 0. So if net state of Q is 0, Q bar is 1. Again I'll take A as 1. If A is 1, it will take Q which is 0. So 0, 0 NAND is 1. So D is 1, Q is 1. Now based on this truth table, let's draw the state diagram. Now see, if Q is 0, let's take the cases of Q is 0, these two. And if A is 0, next value of Q bar is 1. So if A is 0, it will shift to Q equal to 1. And if A is 1, it will again shift to Q equal to 1. So this is how the transition is. Now at Q equal to 1, if A is 0, it will shift to Q equal to 1, which means it will remain at the same place for A equal to 0, Q equal to 1. Now if A is 1, if A is 1, it will shift to Q equal to 0. So A is 1, it's shifting to Q equal to 0. So this is the state transition diagram. I hope you all understood. Please feel free to comment below. Thank you.